Okay, so if I sit back here, does that sound good? Yeah? Okay. Josh brought us together here tonight because we have some overlapping concerns, the three of us, having to do with aesthetics and cognitive processes and interest in color in both the analog and digital age. So I'm going to present some work that I've been doing around a particular aspect of the history of color photography. And it actually centers around some very bizarre images, which I group together under the general term standard reference images. And they've really played an important role in shaping how color images look, both in photography and in printed matter. The use of these images was really tied to the period roughly from the mid-70s through the 90s when analog and digital photographic technologies were overlapping and crossfading, really till the point that eventually digital won out. But I think the history of these images can tell us a lot about how we want our images to look and how and why those preferences have developed over time. I just want to quickly mention, as Josh said, that my presentation tonight is based on an article that I published in June in the magazine Triple Canopy. So I want to thank them for supporting this project. And in the article, I argue several things simultaneously about color photography as a fine art and its acceptance as such, and how the growth of colorful printed matter tied into that, a couple different photo exhibitions at MoMA, and a few other topics. So tonight I'm just going to talk about a couple strands of the article that I think could be relevant to this discussion with Pete and Peter, particularly the overlap of two kinds of objectives in color photography, which is quantitatively managing and measuring color, versus the desire to actually produce pleasing color, which is a subjective question, which is also in part informed by psychophysical phenomena. So this project actually started for me a couple years ago when I was researching which new digital camera to buy, and I went pretty deep into the prosumer review sites online, which some of you may be familiar with. And I noticed that in order to evaluate the qualities of various new cameras, these review sites all had their own version of what they call the studio scene. And these test how digital cameras stack up in terms of resolution and detail, texture, color, this kind of thing. And these studio scenes, for logistical reasons, are still lives. They have to be, because they need to be imperishable and inanimate so that they can be consistent and unchanged as test sites for every new camera that comes under review. So these super kitsch still lifes, which bring together a very weird assortment of products from science and industry and consumer culture, test how well a particular optical recording device, whether a camera or a camcorder, can handle different things like reflected highlights of glass or metal, simulations of various skin tones, bright familiar colors, a really wide tonal range, and fine textures. And to me, they seem sort of like commercial product photography made by someone with terrible taste. And I was fascinated by the aesthetics of these images, and I couldn't stop wondering about how these images were composed the way that they were and why. And one thing that really struck me at the time was how similar many of these images were to certain movements or looks in contemporary photography at that moment. Which, as the artist Joshua Citarella put it, was a moment when it seemed like contemporary photography was only about fruit. And it's true, there was a lot of fruit photography, but also still life in general, very constructed still lifes. And the interest in this kind of still life seemed to me to be not unrelated to a pretty widespread concern in the digital age in how we capture information in images and how that information gets reproduced and disseminated. And so there are certain kind of visual markers that gesture toward that. Color control patches, or the rephotography of printed matter, which helps us understand how images change through iteration, and work that underscores the technical marks of imagery production, which goes back all the way to pictures or pop. Artists reminding us of the role of various technical equipment, like scanners, for example, or how the test targets that control reproduction can also be used to control or surveil us. or work that very self-consciously apes stock photography in a tongue-in-cheek way, reminding us of those generic image tropes. And then there are artists who are working on the technical nature of image making very explicitly, whether by referencing specific film brands or looking into the history of the reference images that have helped shape color photographic and film reproduction. And as I'm sure many people here know, some of those reference images have gained a kind of cult fame for artists and those who worked in some of those labs, especially the portraits. For example, the China Girls, which appeared on leaders of motion picture prints. This is an example of that. The Shirleys, which Kodak distributed to its print processing labs. This is Lena. She was a favorite of scientists who were working on compression algorithms. She was originally scanned from an early 70s issue of Playboy. And I think part of the reason that they kind of developed this cult status is that they, like the still lifes, have this kitsch, dated look, and they replicate certain irritating normative ideals like whiteness, the female is the object of the gaze, and this kind of thing. And also, a lot of the images used to test the effects of compression on texture and detail were very explicitly engineered to be useful in situations of war and surveillance. So this has been really generative for a lot of artists, and maybe none more so than Christopher Williams, whose work has really centered very strongly on pointing out to viewers how industry has shaped what we see, and the technical norms of photography, how different photographic brands differ in their representation, and how we might pay better attention to the mechanics of the entire photographic system. And of course, the interest in helping viewers to understand how images are constructed, how they operate on us, has been of longstanding interest to a number of other writers and artists. And so I became interested in these reference images in all of their various forms as a class, because they sort of seemed to speak to questions of taste and reproduction, and they seemed like they were carriers of information that could maybe tell us something more broadly about photography. So I was very interested in this. Can these images tell us how we want our images in general to look? And specifically, how do we create that and regulate that? And so to find that out, I ended up talking to a lot of scientists. And at the time that I started, nothing really had been published on this technical question. So tonight I'm going to talk about a process innovated by Kodak in the 1970s to produce new color film products, and some of the processes that helped regulate digital imagery production through the 90s and early 2000s. But I'm going to start very briefly all the way back in the 1920s, which was when scientists came up with a model for human color vision. So for a long time, centuries really, the big question for a lot of thinkers was, how can we quantify color? Is that possible? Perception of color has long been considered a very classically subjective experience, which is why it figures in a lot of philosophical thought experiments. Right? We may never be able to know for sure if our perception of red matches our neighbor's perception of red. But scientists and industrialists actually don't care about that at all, because they're really interested in the question of matching color, or using color to indicate something about consistency or quality in a product. And so a lot of different artists and theorists came up with various ways to regularize color, how to plot basically hue or saturation or brightness. We're looking at one by Philip Otto Runge and Johannes Itten. Here's a couple models from Albert Munsell. And so what these kind of industrial applications did was allow someone to grade a product or rate it by visually matching it with standardized sample colors, which had a lot of uses in food and industry and science. But so color appearance is the sum of a lot of things acting at once, which is why it's sort of a devilishly complicated science, because on the one hand we have the surface characteristics of an object, then we also have the light that's illuminating that object, and we have the response of the human eye, and then there's a processing that takes place in the human brain. So in the 1920s, what scientists were really trying to figure out was one part of that complex system, which was to measure the responses of the 3 receptor cells in the human eye. And matching, obviously, like if we're going to check this rotisserie chicken against a Munsell color strip, we need an actual pair of human eyes, right? We need to look at it under a specific light source and say whether it matches. But to measure color in a more objective way, scientists actually needed a theoretical mathematical model of the human eye. So they could have that part of the equation, and they could have information that could be used for computation across time and space. So not a particular pair of eyes under a particular lighting scenario. And so they went about trying to do this. This is a really spectacularly unhelpful diagram of the apparatus that they used to conduct this test. Here's a much better modern day representation. So in the mid-1920s, an optical scientist in Britain basically put together this test that would measure the response of how the short, medium, and long cells in the human eye would receive color stimulus, and how that in turn would blend to combine the colors, the many, many colors that we see. And so he essentially rigged up this divided box, and the test subjects could move the apertures on each of the red, green, and blue lights shining into the left side of the box. And he had very carefully created these gelatin lenses, the wavelengths of which he knew precisely, and he had measured these apertures so he could make this incredible quantitative determination of how much of each of those primaries were flowing into the box to then match the adjacent color that he was testing. So he did this experiment first with 10 young people from his lab, and a couple of years later another scientist did a similar experiment with 7 other test subjects. And they found there was a lot of agreement. So what they did was they realized that they had functionally mapped the visible spectrum, and they had this new quantifiable set of information about how the 3 receptors in the human eye actually interpret color stimulus. And so in 1931, they averaged their results. They decided they were going to call this new theoretical set of eyes the standard observer. And they made a color space, which was a computational space and a sort of quantifiable map of the spectrum. And they presented it to the Royal Society. It became an international standard. And so that super durable data, which is almost 100 years old now, actually came through the subjective vision of 17 young test subjects. And so this information ultimately became really valuable many decades later for the computational work that had to be done to model images, and really helped to control how color would replicate on screens and through projectors and on paper. But the problem with this quantitative system is it doesn't actually solve the question that's super crucial to the photographic industry, which is how can we make images look good? Because obviously chromatically beautiful films make a lot of money. And so ads, for example, in the 60s, advertised the beauty of the colors and how they supported realism, but they were still handsome. And the copy said that they never distorted color, but they were still creative and exciting. So, but then the question is really, how did the photographic industries engineer these films? How was that actually done? Because a huge challenge for imaging scientists is that a photographic image can only contain a fraction of a typical live scene. So the color gamut and the range of tonal gradations that we see in life is just incredibly reduced in every photographic medium. And one of the scientists that I talked to kind of described this fundamental problem of photographic engineering as the issue of having to stuff a very large object into a much smaller box. And so when scientists are engineering this process, what they really need to figure out is where they can sensibly compress information without it being obvious or objectionable to the human eye. And so in order to do that, they have to figure out a rendering. And what that means is basically, in the case of photographic media, they need to figure out how to amplify certain quantities of the counted photons and minimize others. And imaging scientists actually use that word rendering in a kind of interesting way, in that one of my sources likened it to the way that you would think about like the rendition of a musical score or the rendition of lyrics of a song. It's really the way that information is transformed through interpretation, and through artistry, which is over and over what those scientists really spoke of their work as. And so color rendering in photography in particular has to translate what chemical film or an electronic sensor perceives to emulate what the human eye sees, and what the human mind then interprets, while taking into account what the physical medium can actually produce. And so this process, whether it's through chemical reactions or by electronic signal processing, is highly engineered and it's nonlinear. What goes in does not have a one-to-one relationship with what comes out. So the question for scientists is always how to figure out the right way to do this, because it's a question of artistry, of interpretation, how to render this information. Scientists need to test the possibilities on real images. And so Kodak researchers decided that they needed a scene library, a group of reference images, and the staff photographers there at the research labs assembled a couple hundred photos. And collectively, that group of photos tries to encompass a great deal of what would typically be captured on film. So things like picnics, birthday parties, tourist shots, portraits, and so forth. And so Kodak scientists actually used these scene library images for a major initiative, which was the first of its kind, called image simulation, and that started in 1975. And for the image simulation experiment, researchers would very carefully alter the scene library images, scanning them, digitally manipulating them to display particular aesthetic qualities. And then they would actually generate sequences or pairs of these manipulated images and give them to a division at Eastman Kodak called Human Factors. And they would contract with market research firms to take polls and see what the consumers thought. And they often would conduct these in shopping malls and in return for like $20 or a gift card. And so those people taking the polls would ask very careful questions, things like, which of these photographs seems more representative to you? Which has the optimal color? Which of these images do you prefer? And so they made some interesting discoveries about consumer preference and belief. And among the things that they found were that almost all viewers preferred films with finer grain structures. Caucasians tended to prefer skin that appeared tanner in reproduction than in reality. South Asian and Black respondents preferred skin tones that skewed yellow. People wanted the sky to stay blue at the horizon. So even though right at the horizon, the sky is more typically white, when scientists or the pollers asked, which of these looks right? Respondents always said it looked right if the blue continued right down to the horizon. And really, the strongest and most consistent finding across all respondents was a very strong preference for bright, very high contrast versions of well-known colors, with the saturations far exceeding their actual colorimetric values. And imaging scientists refer to this need to generate color that is perceptually enhanced, but it still has to be acceptably faithful to reality, and that concept is what they call the naturalness constraint. So one thing that's kind of integral to their work is figuring out how to make color pleasing, but never exceeding the bounds of believability. And so through these reference images, scientists were able to mathematically model and produce images that realistically simulated the changes that they hoped to ultimately achieve at a later stage in the process by manipulating the chemical reactions of actual analog film. So curiously enough, the digital camera was invented that same year in 1975 at the Kodak Research Labs. But that year, image simulation began, and it was actually the first major digital process that fundamentally changed the way that color film was produced. And so, of course, these reference images had to be stocked with lots of well-known colors, which scientists call memory color. And those are the hues that we know very well. And we're particularly sensitive to these colors, like flesh or sky or foliage, because we have a really strong sense of how subjectively these are supposed to look, because we have common daily exposure. But ironically, Similarly, as the human factors group found, our familiarity with these memory colors makes our mind distort them. We remember and believe grass to be more green, skies to be more blue, apples to be more red. And this was actually something that researchers had known for a long time. One of the first papers written about this for the photo industry was by a Kodak researcher in 1960. Scientists in the 19th century had written about the phenomenon, and painters had known this probably for centuries. And the phenomenon has also been studied in the fields of psychology and psychophysics. Naturally, a lot of fruits and vegetables and skin tones have figured prominently in these tests, because after all, these are colors that are common to human sight. And so after these scene library images had been simulated and then tested in focus groups and malls, renderings that received positive consumer feedback were then tested more closely on what the scientists called box tests. And these were still life tableaus that were stocked with familiar products, often kind of far out hues, a lot of fluorescence, and really highly textured items. Because when you increase saturation intensely, one of the first things that you lose is textural detail. And so these would be filled with what the scientists called created objects, basically items from human industry. And the point was really to make sure that the renderings that looked very pleasing in the more naturalistic scenes wouldn't result in specific memory color errors or this loss of surface detail in these less typical situations. And in fact, one Kodak film was delayed in production during this process for failing to convincingly reproduce the blue of Levi's jeans. So it's actually these box tests, which were used quite a bit in the 80s and 90s, from which we get the aesthetic of the contemporary studio scene that we saw before, multiplying through the camera review websites. And so these reference images helped regulate what we might call first-order reproduction, or the task of making the world into an image. And there's also the related problem, which is reproducing or multiplying those existing photos for distribution on the printed page or more and more on the screen. And actually the images that helped regulate and shape this process are in some ways even stranger than those that regulate photography. But so what are the technical considerations? What are the difficulties of the mass reproduction of color photographs? Because most of us actually see photographs on a printed page, right? That's probably the vast majority of images that we see. And so there's another technical difficulty there. So for much of the 20th century, to make printing plates to separate a color image into 4 component colors, because on a press, a single plate can only hold one color of ink, right? So cyan, magenta, yellow, and black each have to be pressed into the page in succession to create a full color image. And so to split that image into its component parts for that industrial process was done for most of the 20th century by shooting color separations on really huge sheets of film using what was called a process camera and colored filters. And after that, those films then had to be extensively color corrected through additional filtering and rephotography. It was a hugely labor-intensive process. But this complicated, very craft-intensive process was eventually supplanted by the scanner, which was actually invented in 1949. Don't mind the incredibly bad image quality here. So, when you hear the word scanner, one tends to think of a small plastic-covered rectangle that sits on your desk that's kind of made for capturing a digital file of an image. But that entire technology, scanners, as they were originally invented, were created to optically split color photographs, not for the purpose of digital capture, but to divide out the colors necessary for the printing press. So it was invented specifically for the graphic arts industry. And it was just a huge boon, basically, to the industry, because in the 60s, for example, separations made by analog cameras for offset printing could take maybe 2 days to produce. And already by the mid-70s, when separations were regularly being made through the scanner, they could be prepared in less than an hour. So this switch to signal processing was huge. It meant that basically this entire process of photomechanical reproduction was a much more consistent and replicable process. But it had its own problems. Basically, because optical devices don't perceive color like the human eye does, scanners could often just distort what they saw, and this distortion could actually make the print job unsaleable. And so, whereas once people who worked in a press room would understand how to separate color as a craft process using these big cameras and doing manual color correction, they had to be completely retrained with the advent of the scanner, which at the time that it was gaining use had no type of video monitor or any previewing. In other words, these scanner operators had no idea what was going to come out the other end. So on the one hand, they had to calibrate their machines, which is why these sort of objective color patches were very useful. But the other thing they really needed was images that they could judge subjectively. And so to educate this kind of group of press workers, Kodak produced this guide. They called it the Q60, came out in '77, and they updated it in the following years. And the scanners could be calibrated material by material. So Kodak was doing this, but when I say Kodak, it's kind of standing in for all of the major producers. Because the other tricky thing about this move to digital is that a huge number of physical media suddenly had to enter the same stream. So it used to be the case that like all of Playboy was shot on Ektachrome, or a magazine would have like a workflow in which a single type of analog media was used because they understood the physical quantities or qualities of that media. Now presses had to understand how an Agfa film, a Kodak film, a Fuji film would all enter and be seen by the scanner and how those different colors would be interpreted. And so what they needed, in addition to information about how to calibrate for these different materials, they also needed to understand how manipulating that data that they couldn't see would change the color balance or the tone gradations, and how that would in turn affect the final printed page. And so these are the two standard images that Kodak first released in the 70s for scanner training. And these were really important because at the end of the day, calibration can only get you so far. What you really need, what the customer really wants, is an image that looks right. They want the pleasing image. And so for that, they really needed this set of reference images for judgment. And so that original Kodak guide with 2 reference images eventually expanded to include a few more images in 1988 when they revised it. I love these ladies. So these reference images were really just helping to make legible to press workers how manipulating that immaterial color information would change the look of the mass-produced image. And they were facing a really similar thing to the imaging scientists who were working on photography, because they had to abide by the naturalist constraints when they were developing film products, and so too did the color separators need to make sure that images were bright and snappy, and that they either reproduced whatever chromatic distortions were built into the original photograph, or even more often, the customer would request that there would be additional distortions. And again, they had to deliver that without veering too far into unbelievability. And so at this moment, Kodak and Fuji and other companies were making these sort of proprietary guides. A lot of international trade groups related to printing wanted to make their own group of standard images, and that was in reaction to the industry globalizing. And the idea of having standard images for them was really about reproduction being able to be tested across time and location. So a customer might be in New York, the printing press might be in Singapore, but they can share a set of common test images. And so to make that happen in the early 90s, the International Organization for Standardization began the process of creating a set of standard natural images, and they distributed them as digital files to presses and users around the world. And this sort of major visual tropes of the reference genre are all accounted for. There's the portrait and the street scene, multiple still lifes, And together, these represented kind of an array of visual stressors, qualities that can catch errors in reproduction, and loads of memory colors, neutral tones, plenty of highlight and shadow areas. And so you'll notice the three musicians actually came from Kodak from their earlier proprietary guide. And I just think there's something kind of amazing about this idea of making a set of standard images to stand in functionally for like the entire image world. And they're really designed to help printers fulfill their customers' desires. And in general, as one of my printing sources told me, those desires can be summed up by an aphorism that a lot of people in the industry like to say, which is, clean and bright is always right, dull and gray is not the way. And so these were really useful to people in industry, and so the ISO actually released further sets of images, which were digitally encoded in different ways, and this allowed people to test different kinds of transmission and processing. And at the same time that this was going on, desktop publishing was exploding as well, because suddenly there was the availability of much more powerful home computers. So scanning and preparing images for reproduction wasn't just something done solely in an industrial setting anymore. And graphic designers and other users, just like the scanner operators, had to be trained to understand how color images would change as they shifted from the screen to a piece of paper and so forth. And so stock licensing and image editing companies began to produce free test files to distribute to customers, again, to help them figure out how to regulate the consistency of color and detail and resolution as they pass through different physical instantiations. And since these companies often only wanted to distribute a single image rather than a set, they tended to pack these test images with as much flesh tone and highlight and shadow and texture and memory color as they could possibly cram into a single frame. And the one we're looking at now is from the world's first all-digital stock photo company, and this is from the early 90s. So as images became a digital product, they needed to have images behind those images to help regulate how they would look. This is one that was regularly bundled with Adobe Photoshop starting in 1994. They call it Olé no More. And her Carmen Miranda getup has a nice still life on the head. This is one that is now defunct, but it was distributed by Getty Images. They're so serious, these ladies. So yeah, and so this trio of women with their various flesh tones preside over the usual assortment of still life objects, providing all the usual content. So when I started, I really wanted to make sense of these images as a class, and what I came away with was a sense of the sort of two countervailing forces that they embody. Because on the one hand, the reference images point to this slippage between technological and mathematical precision, and on the other, there's the pull of preference. So as strange as these images are, they really represent our struggle to extract a consistent, but also a consistently pleasing representation of the physical world. And I'm kind of interested in that way that they literalize our very vexed relationship with realism. So in that, if they look kitschy or artificial, they are doing so very carefully in service of processes that allows industry to measure and manipulate all images. And ultimately, they exist really to fulfill our taste. They're made to create certain feedback loops to regulate and shape and fix images so that they please us. And that, for me, the fact that such unnatural and unlovely images would regulate our shifting ideas of what is natural and what is pleasing is exactly what makes them so compelling and, I think, instructive. That's it.